Hello everyone. Today we'll be discussing about few questions of ISC board 11 science, 11 science and arts for maths. So I'll be covering some 6 parts. This is the first part where I've taken these 5 questions which will be useful for covering the chapter called trigonometry. Now let us go ahead. Now this particular question says cos cube minus sine cube a upon cos a minus sine a. Now, what we need to understand is this question. You will have to first see how do we solve this. We can solve this by ensuring that this sine cube, cos cube minus sine cube is of the form of a cube minus b cube. So a cube minus b cube is a formula which is a minus b into a square plus ab plus b square. Therefore, we can write cos cube minus sine cube as cos a minus sine a into cos square a plus cos a sine a plus sine square a. So this can be written as cos a minus sine a into cos square a plus cos a sine a plus sine square a. Further, this cos a minus sine a in the numerator and in the denominator will get cancelled. What will remain is sine square a plus cos a sine a plus sine square a. Further, by using the identity sine square plus a plus cos square a is equal to 1, we will get this portion as 1. What we get is 1 plus cos a sine a. This can also be further reduced if we remember the formula of sine 2a. So we will multiply this by 2 and we divide this by 2. This becomes 1 plus 2 sine a cos a upon 2. We also know that sine 2a is 2 sine a cos a. Therefore, the answer will be 1 plus sine 2a upon 2. If you want to write down, you can write down. If you want to take a screenshot, I will just quickly clear all the green areas. Now you can take a screenshot now of the answer. That was the first question. Let us move to the next question. The next question is, if tan 25 is equal to a, prove that tan 155 minus tan 115 upon 1 plus tan 155 into tan 115 is equal to 1 minus a square upon 2a. Now in this question, as a first instant, we will think that we can use tan a minus tan b upon 1 plus tan ab. But no, here it is given that tan 25 is equal to a. So we need to try and convert these tans into something which gives you 25. Now what I feel is 180 minus 25 is 155 and 90 plus 25 is 115. We'll try to use that. We write the question again. Instead of 155 here, we will write 180 minus 25 and tan 115, we will write tan 90 plus 25 and similarly in the denominator. Now I have already explained you in the previous chapter that how do we find out signs of every quadrant. So in first quadrant, both cos and sine are positive because x represents the cos and y represents the sine. In the second quadrant, it is minus and plus. So your cos is negative and your sine is positive. In the third quadrant, both are negative, cos and sine. In the fourth quadrant, cos is positive and sine is negative. Now, tan 180 minus 25 is in the second quadrant. And you can see that the tan will be negative if one of them is positive and negative. So therefore, tan 180 minus 25 is going to be minus. Tan 90 plus 25 again in the second quadrant. So whenever you have a multiple of 180, 360, you get the same thing. So tan is converted into tan, whereas when you have 90, it is converted into opposite. So tan 180 minus 25 can be written as minus because of the second quadrant and tan 25. Tan 90 plus 25 will be written as cot 25 and a negative sign because it's second quadrant. Similarly, in the denominator also we will write 1 plus minus 25, tan 25 minus cot 25. Further, this minus sign will change and we can directly write it as this minus minus will become plus. Similarly, this minus minus will become plus. Tan 25 is given as a. So minus a plus 1 upon a plus upon 1 plus a into 1 upon a. Because tan 25 is a, so cot 25 will be reverse of that. What we get is in the denominator is 1 plus 1, 2. And in the numerator we will get minus a square plus 1 upon a. Which can be written as 1 minus a square upon 2a. This was the second question. Let's move on to the third. In case you want to see this question completely, let me just remove the green text so you can clearly. You can take a screenshot or you can write down the answer. Let's move on to the third question. It says prove cos A plus cos B upon sin A minus sin B raised to n plus sin A plus sin B upon cos A minus con B raised to n is equal to 0 if n is odd. And whereas if n is even, this thing will become cot 2 cot raised to n A minus B upon 2. So let us simply start with what is given in the question. Cos A plus cos B upon sin A minus sin B raised to n plus sin A plus sin B upon cos A minus cos B raised to n. We will use all the sum and difference formulae which you studied in trigonometry, which means cos A plus cos B, sin A plus sin B, sin A minus sin B, and cos A minus cos B. So let's recollect all the formula. For cos and cos, it was 2 cos A plus B by 2, cos A minus B by 2. Whereas for sin A minus sin B, it was 2 cos A plus B by 2 and sin A minus B by 2. Whereas when both were sin plus sin A plus sin B, it was 2 sin A plus B upon 2 cos A minus B upon 2. And for cos A minus cos B, it was minus 2 sin A plus B upon 2 sin A minus B upon 2. Now you can see that the common terms like 2 and cos A plus B by 2 will get cancelled. Here 2 and sin A minus plus B by 2 upon sin A plus B by 2 will get cancelled. What remains is cot A minus B upon 2 because cos upon sin is. So we will get cos A minus B upon 2 upon sin A minus 2 raised to n plus cos A minus B upon 2 upon sin A minus B upon 2 raised to n minus, sorry. Then this means cot and sin will be cot. So cot A minus B upon 2 raised to n plus will be a minus here minus cot of A minus B upon 2 raised to n. This can further be written as minus 1 raised to n here. The remaining term remains the same, cot of A minus B upon 2 raised to n plus minus 1 raised to n into cot of A minus B upon 2 raised to n. Now, if n is odd, which means whenever there is an odd multiple of minus 1 raised to 1, minus 1 raised to 3, minus 1, it will be minus 1. So we can write that value, cot of A minus B upon 2 raised to n minus cot of A minus B upon 2 raised to n. So this cot and cot will get cancelled, you will get 0. Whereas if n is even, then this minus 1 will become plus, which means cot A minus B upon 2 plus cot A minus B upon 2 raised to n, which means it will be 2 cot A minus B upon 2 raised to n. Now I just remove this in case you guys want to write or take a screenshot. You can. This is the third question of the ISC portion for 11th standard maths. The next question is, the 3 tan x, tan y, and tan z are given in GP, that is geometric progression. You have to prove that cos 2y is equal to cos of x plus z upon cos of x minus z. And in this question, we will start with something called a GP. So if 3 numbers A, B, and C are in GP, then we can clearly write that the square of the middle number, that is B square, is equal to AC. That is because B upon A will be equal to C upon B. That is a geometric progression. So B square will be AC. Now since tan x, tan y, and tan z are in GP, we can say that here tan x is A, tan y is B, and tan that is C. So we can say that B square equal to AC, which means tan y square is equal to tan x into tan z. That is your B square equal to AC. Further, tan x can be written as sin x upon cos x. Tan z can be written as sin z upon cos z. Now we will take a reciprocal. This is a very important step because you want to do something. We will take a reciprocal. It will become 1 upon tan square y is equal to cos x cos z upon sin x sin z. Further, in the next step, and a very important step, is taking componendo and denominator together, which means numerator minus denominator upon numerator plus denominator. So this will become 1 minus tan square y upon 1 plus tan square y. Why we are doing this is because we want to get somewhere cos 2y. On the right hand side, it will become cos x cos z minus sin x sin z upon cos x cos z plus sin x sin z. Further, as I said, the left hand side will become cos 2 theta because 1 minus tan square theta upon 1 plus tan square theta is cos 2 theta. So this will become cos 2y. Here it is cos A cos B minus sin A sin B. This will be cos A plus B and denominator will be cos A minus B. So cos x plus z upon cos x minus, which is what we need to prove. I will once again give you some time to write down, and I'll remove this text, green text. You can. Now let's move on to the last question of this first part of ISC 11th standard maths. Is Prove that, now this question is just a little correction here. It will be cos A minus cos B the whole square plus sin A minus sin B the whole square is equal to 4 sin square A minus B by 2. So this is A minus B by 2 the whole, like the theta value. Now let's start this question. We will take the LHS as cos A minus cos B the whole square plus sin A minus sin B the whole square, which can be written as you know that A minus B the whole square is A square minus 2AB plus B square. We can write it as cos square A minus 2 cos A cos B plus cos square B. This is A square minus 2 cos 2AB plus B square. Similarly, I can write sin square A square minus 2 sin A sin B plus sin square B. In the second step, we will try to combine all sin square and cos square. So sin square A and cos square A can be combined. Similarly, cos square B and sin square B can be combined. And the remaining minus 2 cos A cos B minus 2 sin A sin B can be written like this. Now in this, sin square A plus cos square A is equal to 1. So we can further write both sin square A plus cos square A and sin square B plus cos square B as 1 plus 1. Minus 2 we will take common. We will get cos A cos B plus sin A sin B. Now this is also a formula, if you can see further, that's cos A cos B plus sin A sin B can be written as cos A minus B. This which mean we will have 2 minus 2 cos A minus B. You take 2 common out, we will get 1 minus cos A minus B. Now this is similar to 1 minus cos theta. 1 minus cos theta is 2 sin square theta by 2. Similarly, here theta is A minus B. So this will become 2 sin square A minus B upon 2, which will become 2 into 2, 4 sin square A minus B. I'll just remove the green text for you to write the last answer. So these were all the questions which I had to discuss, which are important from the point of view of 11th ISC examination. Prepare well for them. And this was the first part. Do subscribe to our channel. Do like it if you enjoyed watching this. And I will be posting 3-4 more parts of these 10-12 minutes video, which will give a good insight about all the difficult questions of ISC maths. Thank you so much. Bye-bye.